Okay, welcome back into the NWS Columbia podcast with your host, Pierce Larkin.
And your co-host, Pierce. Co-host.
Oh, sorry, co-host. We are hosts and co-hosts.
Yes. Matt Gropp.
Yep. We are back with another episode. It's going to be a fire episode today. Hopefully you enjoy it. So we're going to start off by talking about why we actually got into meteorology. Then we're going to do our weekly segment, Word of the Day. And then that's going to be followed by an interview with another National Weather Service meteorologist. Our subject today is Hunter Coleman. That'll also get us into our weather event of the week. And then, what's our famously hot takes about today?
They're going to be about severe weather parameters.
Heck yeah, they are. Okay, so we got a lot to pack into a hopefully 30 to 40 minute episode here. So let's get started. Matt, what are our career arcs like? Why did you get into meteorology?
Sure. So I'm a fairly typical meteorologist. I've been interested in it pretty much my whole life.
Yep.
The thing that triggered it was the blizzard of '96. I grew up outside Philadelphia, and that was still to this day the biggest snowstorm in the city's history. We got 31 inches of snow at my house just west of Philly, and I was pretty young at the time, and I had one of those like toy lawn mowers. And it was completely buried. I remember being very sad. That's about my only memory of it. But I know after that day, I've always had an interest in weather, following a blizzard like that. So after that, I always had kind of an enthusiast interest as a hobby going through middle school and then high school. Knew I wanted to go do it in college. Being from Pennsylvania, I ended up going to Penn State. They have a big meteorology program there. Then after I did that, left the field for actually a year. Went and worked for a satellite that had nothing to do with meteorology.
Wow.
It was an astrophysics satellite.
Whoa, was that NASA?
That was not with NASA, but it was a NASA sponsored.
Oh, dope.
Yeah, we
That's
looked
cool.
for gamma ray bursts. Shout out to the Swift telescope.
Oh, wow, that's cool. Yeah.
Swift telescope.
Yeah,
Look
gamma
it
ray
up.
bursts.
Yeah, it was cool stuff.
That's a rabbit hole. Go down that rabbit hole.
Very different.
Gamma ray bursts.
Yeah, very different field.
Yeah.
Much more high energy than anything on Earth, thankfully. So then from there, I knew I wanted to get back into meteorology just after leaving it for a year. Went to UNC Charlotte for my master's degree. Stayed for that for 2 years and then continued on to do a PhD, which I am still working on now, which is in meteorology as well. Eventually I realized I didn't want to do academia, so left that, applied for the Weather Service, and now I'm here. I've been here for 2 years now.
Yep. Sweet. Yeah, my career arc is similar in some parts, a little bit different in others. I was definitely a traditional student of the atmosphere, which I fell in love with.
Student of the atmosphere.
Yes, I fell in love with it at a young age, just like Matt did. When I was in third grade, may have been second grade, I can't remember. It was one of the two. My mom said this happened earlier, but this is the event that I remember it with. In 2004, there was a tornado that struck Lexington, Kentucky. I grew up in Kentucky, just outside Lexington, and a tornado struck Lexington in the middle of the night. It ended up being, I think, an F3, struck the largest neighborhood in the state of Kentucky.
This was before the EF scale.
Yes, this was prior to the EF scale, so it was an F, an F3. And the next morning, my parents told me about it, and I was like, whoa, that's cool, a tornado. So I had someone at my school teach me how to draw tornadoes. And it's just taken off ever since.
Like draw them.
Yeah, like draw. Like draw them. Yeah, yeah. That's how it started. And I remember in third grade, I checked out a book from the library about tornadoes in the super outbreak. One hit Louisville, Kentucky.
So when was the super outbreak?
April 3rd, 1974. April 3rd and 4th, 1974.
Okay. That's the second biggest tornado outbreak in the U.S. history, right now, behind April 27th, 2011.
Yep. And so I was just like, I was just obsessed. Got in trouble all the time for reading books in class and stuff like that. It was kind of ironic. Elementary school, they want you to read, and I was getting in trouble for reading weather books.
They were trying to knock down your creativity.
Yeah, they were. They really were.
You were crazy. You were an atmospheric scholar.
At a young age, oh yeah. So I, from there, it was just like Matt. I'm an enthusiast through high school. And I wanted to go to college for it, so I went to Western Kentucky University. Shout out to the Hilltoppers.
Great mascot.
Yes,
Maybe
it is.
mascots.
It's a great mascot. Big Red. Look them up. And look up Big Red holding a football. It's so great. the mascot. I got a T-shirt of it and everything. It's so great. But went there, really specialized in operational meteorology. And so after that, I spent a couple years doing GIS work for an energy company in Tennessee. And then I got the job here, and I've been here for almost 3 years. It'll be 3 years in June. So
you've had a flavor of the academic side, obviously getting your degree, then private sector, and now government.
Yep. So I've had pretty wide variety of things I've done. I thought about going into academia when I was in college. I still love school. I love tests and stuff like that. Loved all that stuff.
A true scholar.
Yeah. So I thought about going into academia, but honestly, going the operational route here with the National Weather Service was a good decision.
Okay, so that kind of ties us in. We're both, on the weather nerd side of things.
Yes,
I would say.
Are. Yeah,
we pay attention to the weather outside of work.
Yep.
In other parts of the country. Not everyone's like that.
Yeah.
You don't have to be that to be
not at all.
interested in meteorology, to get a job in it. There's multiple people here in our office who are, I would say, professional meteorologists who don't have a kind of hobbyist side.
They unplug. They unplug.
When we're outside of work, we're watching, the radar for tornado outbreaks out west and stuff like that. But not everyone's like that. You don't have to be.
Mm-hmm.
So let's get kind of into the different ways, if you wanted to get into meteorology, what are some of the different options? And specifically, since we're here at the Weather Service, how you could get involved at the Weather Service or get a job at the Weather Service. So the primary route that people go, obviously, is college. To get into the Weather Service, you have to have a certain amount of credit hours and a degree from an accredited institution that has a meteorology program. So getting a meteorology degree is important from a 4-year program. Having a master's degree helps, but is not necessary. You can go to graduate school. There are even different routes of college programs that you can go into. You can go to larger schools such as Penn State, Florida State, Oklahoma, where they're centered at research institutions, so that you can you can specialize in a lot of different stuff. That might be better if you wanted to go into academia or something, but there are also smaller programs that are really niche, doing media stuff, broadcast, operational impacts, stuff like that. Yeah, so that's kind of going to college is route one.
Yeah.
And a lot of people in the Weather Service now are. The other options are you can come from the military. Military does specific training on, I believe they're called weather observers.
Yeah, weather observers.
Yes.
Yeah.
So there's multiple people here in our office who are vets who came from the military directly into the Weather Service and continued their civil service that way. Obviously, if you don't want to do it as a career, there's plenty of options to get involved in the weather community as an enthusiast.
Yep.
There's tons of people with YouTube channels, and on social media platforms you can follow all sorts of either national level weather enthusiasts or meteorologists or people locally in your community.
Yeah. There are also, even if you want to do it on a smaller level than that, you can be a co-op observer, sending in observations to the Weather Service every day. CoCoRa's, where you send precipitation reports every day. So there are a bunch of different ways to actually be. You can be a skyward spotter, take a spotter course. There are a bunch of different ways to actually be involved in the weather field, actually having to go and actually be a meteorologist.
Yeah, we'll do a pretty big deep dive into kind of the volunteer / public service aspects that you can do as a volunteer. To either help the Weather Service out or just become involved in general in the weather community. Yeah, Pierce mentioned the co-op observers. We'll do a segment on that with our observational program lead here, Doug. He'll talk more about that if you have any interest in doing that. Same thing, with the skyward spotters. That just gives you kind of a route and the training to be able to submit severe weather or any kind of weather obs to us. So.
Yep, we really appreciate our volunteers here in the Weather Service. They're usually weather enthusiasts themselves. And so, we appreciate having them giving us extra observations throughout our forecast area and stuff, helps us verify stuff. So just shout out to them.
Okay, so we will discuss more on specifically, if you want to get into the Weather Service as a career rather than a volunteer. We'll do a specific podcast on that because it is...
It's kind of, it takes a lot. So it's just, there's just a lot of nuance in the application process. There are little tips and tricks to setting up your resume to be, filled with stuff that's actually going to, help you stand out if you're a college student listening to this. So there's just a lot of different, there are a lot of different routes to go into, but actually getting into the Weather Service, there's some nuance and stuff. So we'll have a whole episode where we kind of deep dive that.
Yeah, there's some things that specifically have to be on your resume that you might not think about, and the system that kind of scans the resume will basically just discard your resume if it doesn't have these certain things.
And they won't let you know. So,
yeah, and you won't know what went wrong.
Yeah, so that's just one thing that we want to take a little bit more time to explore and talk about. So that'll be coming at a future date.
Okay, so if you have any questions about how to get involved in the weather community in general, or here with the Weather Service, just send us a question through social media, YouTube comments, email, call us. Doesn't really matter.
Yeah, and we'll help you get set up. So now we're going to transition into our word of the day.
That was the country jingle.
That wasn't the country jingle.
That wasn't the country jingle.
It was like do. Word of the day. Word of the day. Something like that.
That's pretty good.
That'd be good. Yeah.
Pierce is from Kentucky. So
I am. Yes.
He knows the bluegrass scene.
Apparently, I have an accent, but I don't notice it. Other people notice it. I don't think I have an accent.
It's not very strong, but it's distinct.
Yeah. Comment below if you think I have an accent. So our word of the day today is taken from our area forecast discussion. Instability. Matt, why don't you talk about instability?
Sure. Instability is one of those kind of nebulous meteorology words that you'll see a lot.
It's like catch-all.
Yeah. It kind of implies a lot of different things. There's different ways to measure it. But generally, instability is basically how much buoyancy is available in the atmosphere for rising motion to occur. So we talk about instability. It's if I take a big balloon of air and I release it, how fast is it going to rise, essentially?
Yeah.
So you can think of when you put helium or hydrogen into a balloon and it rises, that creates an instability between the air in the atmosphere around the balloon and the balloon itself. And that's just due to the buoyancy of the hydrogen or helium inside the balloon being lighter than the air around it. So that same thing can happen in the atmosphere when we just have hotter or more moist air, where the hotter or more moist air is actually lighter and more buoyant than the colder / drier air that's around it. So the one way we measure that, and it's pretty much been that way for the last, 80 years probably, maybe longer, is CAPE, which you'll probably see a lot of anytime there's severe thunderstorms or anything like that discussed. And CAPE stands for Convective Available Potential Energy. So kind of when we were talking about buoyancy, we're just saying convection is basically just buoyancy. The available potential energy is just how much buoyancy is available for that air as it rises in the atmosphere.
Usually you need a lifting mechanism to actually get the air to rise. But
right. So usually the atmosphere
it's what's available.
Right. Usually the atmosphere is fairly stable. It doesn't really move all that much.
Yes.
But when you have something like a cold front that comes along, that can force some air to rise. And as it rises, CAPE measures how much that air will continue to rise, basically. And that's usually measured in just units of energy, because it's potential energy. So measure that in joules per kilogram. Don't really need to know what that means exactly.
It's just a unit.
Yeah, it's just a unit. But generally, once you start getting over 500 or more joules per kilogram, then you're starting to talk about a fairly unstable atmosphere.
Especially locally. It changes throughout the country. In the southeast or the southern United States, typically only need 500 to 1,000 joules of CAPE to get severe thunderstorms. But in the Great Plains, you might be looking at values 1 to 2,000, maybe upwards of 3,000. And so, it just kind of depends on where you're at geographically, what is high and what's not.
Right. So out in the plains, they can generate just insane amounts of CAPE, where they get really, really moisture-rich air that comes up from the Gulf of Mexico. Combine that with the cooler, drier air that comes off the Rockies, and that sets up warm air with cold air above it. So it's a very, very buoyant atmosphere. And they can get CAPE values like 5,000 plus out in the plains pretty consistently. Here in the southeast, we occasionally do see values like that. I think it was in, I can't remember the year where we set our record high temperature here in Columbia.
2012.
2012. Yeah, we had CAPE values that were like north of 6,000 across South Carolina.
It's pretty ridiculous.
Probably I think it's our record high CAPE values. And that's about as high as we can get here. But that also required literally the hottest temperature the city's ever had. So it's pretty rare that we can match the plains for CAPE. So that instability is a way to measure potentially how strong those convective updrafts are going to be in thunderstorms. So like here in the summertime, we generally have a decent amount of CAPE, like in July and August.
2,000 to 3,000. We get strong thunderstorms out of that every afternoon along little weak boundaries. Sometimes the sea breeze comes up and forces that. But yeah, generally in those times we don't have a lot of shear, so they're just kind of general afternoon thunderstorms. Can be briefly severe. When you've got the combination of instability, and last week we talked about shear, when you've got the combination of instability and shear, that's really when you're looking out for big severe thunderstorm events.
Right. And usually those two things line up most often in the spring, where you have enough instability and a lot of shear to cause big severe weather outbreaks.
So that's your word of the day.
Yeah, instability or CAPE, I guess both.
Yeah,
really.
Yeah, instability or CAPE, brought to you by the FV3.
Which
always goes bananas.
Loves CAPE.
It loves CAPE.
The FV3 is a weather model.
Yes, it is a weather model. But that's the word of the day was brought to you by the FV3.
Okay, so going away from our word of the day segment, we're going to go into our interview with the big hunt.
4.6 man himself.
We'll get into more about what that means. We have with you lead forecaster Hunter Coleman.
Thank you.
Welcome to the set, Hunter.
Thank you. Appreciate it.
Okay, so since we started this segment with talking about how we got into meteorology and how we're both kind of weather nerds. Tell us a little bit about how you got into meteorology. Are you a weather nerd? And kind of a little bit about your backstory and how you ended up in Columbia.
I've always, as a little kid, I really enjoyed weather. Always liked looking at clouds and stuff. Loved thunderstorms when they came through. But the big weather event that really kind of locked me into a career in meteorology was Hurricane Hugo. It came through. I grew up in Charlotte, North Carolina. Hurricane Hugo blasted through there a couple days after my birthday and wrecked the entire neighborhood, which is pretty incredible for 110 miles inland from that kind of a storm. So that was really the one event that really got me into my weather career.
So Hugo was it's kind of the benchmark for hurricanes in South Carolina. It was a Category 4 when it made landfall basically in Charleston.
And it was Charleston.
It was moving at like 40 miles an hour when it made landfall. So the damage impacts went really far inland through Columbia all the way up into Charlotte. I think they had like a 90-mile-an-hour gust in Charlotte. So
it was pretty crazy. So that's cool. All three of us, big events, got us.
Am I a weather nerd?
Are you a weather nerd?
So where do you fall between professional meteorologist and weather nerd, but who also does it for a career?
Yeah, I'd probably definitely in the middle of the spectrum there. Maybe slightly towards the professional side. But I do look at the weather outside of the office times.
It's kind of inevitable. Even the people that claim they're professional meteorologists still pay attention because weather's around you all the time. I was
going to say, I always tell my wife that it's like impossible for me to actually unplug because weather's not like a lot of careers. You literally can't unplug from it. Everyone experiences weather all the time.
It's always happening somewhere.
That's true, but I will say I've seen you two guys in action, and when there's storms going on the plains, y'all are all over it.
We are.
I'm not over it. If it's not around here, I'm not really paying that much attention to it.
Hunter's definitely on the more professional side, less weather nerd of things than Pierce and I. So
that's true.
Okay, this could be it could be because of my age. 20 years ago, I probably wasn't y'all's realm. It's
you just chilled out.
Trending more.
Chilled out.
We grew up more in the social media age of everything happening all the time. So.
Okay, so what's your favorite type of weather to forecast for? What's your favorite thing to do in here?
My favorite thing to do is actually work severe weather events, working the radar. That's probably my passion. I love doing that. I like the fast impact of it. I like the benefit of serving the public. That's really what we're here for, trying to protect lives. So I really enjoy that aspect of it the most.
Yeah, I think we probably both fall in that camp as well. So what are your passions outside of work? What's your biggest thing outside of work? What do you love to do?
I love fitness. I love to work out. Love to play sports. Love to just be active all around. Play all kinds of sports: golf, paddleboard, and basketball.
I don't want to give Hunter's age away, but I'm going to just because this is impressive. So let's just say Hunter is 48 years old, and a few months ago he claimed he could run a sub 4.7 40-yard dash. And I said, there's no way this could happen. No way.
You said you can't do under 5.
Yeah, I didn't think you could do it under 5.
So some context to this. Hunter did play Division I baseball in college, and he was an outfielder. So
He was fast.
We know he was fast.
Yeah.
The question is, at 48, is he still that fast?
And
the definitive answer is
yes.
Is yes.
Yes. We Matt and I both timed it. We all ran 40-yard dashes that day. Matt and I were lucky to walk away from that.
We were still faster than Tom Brady's 40-yard dash.
Oh yeah, true. That's true. We were.
You guys did surprise me with your
Yeah.
speed.
Yeah, I was sub 5 myself. I was pretty impressed by that.
Yeah, that was very impressive.
Yeah, no training. So, but Hunter, Matt and I both we both timed him, and he came in at 4.6, which was pretty unbelievable. I mean, honestly, I wasn't like necessarily that surprised, but it was pretty incredible. So yeah, definitely a fitness guy. So so you've worked some big events in your career. What are the biggest events that you've worked so far in your career? Well, how long have you been in the Weather Service? I think that's a good place to start.
I'll give you my history there. So I joined the Weather Service after I went to college, UNC Charlotte, played baseball, like you guys mentioned. Went to University of Wyoming for graduate school, got my master's degree there. Then I got into the Weather Service as an intern at Dodge City, Kansas, back in 2000. Stayed there for 18 months. Didn't stay long. My wife, when we drove into town, she cried. Called her dad, said, "I don't think I can do this." I told her as soon as I get off the probation, that comes with every job when you first join in, you get a year probation. Once I get off that, I'll try and get back further east. So then we went to take a promotion in Charleston, West Virginia as a meteorologist there in 2001. Stayed there for 5 years and then lateraled down here to Columbia, South Carolina in 2006. And then been here ever since.
Yeah, cool.
So back close to home. Carolinas is where we grew up.
I've heard it's windy in Dodge City. Can you confirm?
Yeah. I can confirm it. It is windy in Dodge City and in Wyoming. It's extremely windy and much drier.
Yeah, definitely.
Yeah, those windy days we have here are just like normal days in
seriously.
Dodge City.
So lower than normal days.
Lower than normal. Yeah. Like a 30
15 to 20 is standard out there.
Just stock all the time.
Yeah.
So.
Yep. So, okay, what are the biggest events that you've worked here since you've been here?
Yeah, two major events that I think of. I worked as a radar operator for both of them. Back in March 15, 2008, there was a big supercell outbreak that we had. A lot of people remember that because that was the day before in Atlanta the storms hit the Atlanta Superdome and the SEC tournament was going on. And then more recently, April 2020, tornado outbreak that we had here. Which unfortunately killed a couple of people in our area, and it was just an incredible event especially given the time of day, generally pre-dawn hours, to have the instability that was observed that day was just ridiculous.
Yeah, so Pierce will cover kind of some of the general characteristics of that event, but it happened to like between 4 and 6 a.m. Across the kind of the CSRA from Augusta all the way into the Columbia area.
Yeah.
And it's probably, like we were talking about Hugo, maybe the benchmark for a tornado outbreak.
Across South Carolina.
For central South Carolina.
Even South Carolina in general.
Yeah.
Overall in the U.S., the 24-hour period, I guess it was probably like 25 hours or something, between the morning of April 12th and 13th, 2020, there were 141 tornadoes, 3 EF4s, and 13 EF3s across the southeastern U.S. Locally, we had 8 tornadoes. We had 5 EF3s, I believe 4 of which were on the ground at the same time at one point. 2 people, unfortunately, lost their lives with 7 injuries, which, I mean, honestly, for tornadoes that strong in the middle of the night, I mean, that's crazy. Those tornadoes were, that's incredible it wasn't higher. Those tornadoes were really strong. There were 2 EF2s and 1 EF1. It occurred in a strong line of thunderstorms that pushed through the central and southern South Carolina, and they actually had embedded supercells within them, one of which actually produced an EF4 in Charleston's area, and went on to produce a family of tornadoes throughout the low country of South Carolina. It was a pretty incredible event, honestly, especially for, like kind of we're saying, the time of night, the portion of the country that it was. I mean, it was pretty unbelievable to see that many tornadoes and that many strong tornadoes occur at night. You were primary radar operator that night, weren't you? Yeah,
I was lead forecaster on shift, primary operator. I made a decision at the time when I saw things starting to unfold that we have another forecaster would do just severe thunderstorm warnings. I would take over just issuing tornado warnings. So I could focus just on that and picking those up. And when things started going, it unfolded really, really rapidly. And there, like you said, there were multiple tornadoes on the ground at the same time. And it was pretty high stress situation, especially at the end of a midnight shift.
Yeah.
Yeah, so
Well, and this was right after all the COVID restrictions had started as well.
Right.
yeah, so this was right like basically a month into COVID.
Uh-huh.
And so you came in at 11 o'clock p.m. the night before for the
Right.
midnight shift.
Correct.
So yeah, you're already working 7 hours watching this approach,
Yeah.
and then
And
you
this was
start.
my last midnight shift. It was
Oh, boy.
number 6
Wow.
of 6.
So last of a string of 6.
Yep.
And then this happened. So,
Yep.
so how many people total were on shift?
I think 6.
Okay. Yeah, that's
That's-
pretty good staffing
Yeah.
for a midnight shift.
Yeah, well, especially a midnight shift in the middle of COVID as well,
Yeah.
because we were restricted. We had maximum telework operations, so you really only had 2 people in the office maximum for every shift.
Yeah.
We were talking last week about the structure. On most days we've got the office filled with people and stuff, but during COVID it was really limited to the managers were almost never in and stuff. So this is really impressive that to have Mike and Hunter working the radar that night and getting everything issued and taking care of that event. And it was pretty impressive to be able to do it with the restrictions that we had. And I think the office actually got a silver medal from the Department of Commerce for that. So
Yeah, I believe that's a pretty tough event or award to get.
Yeah.
For a forecast office.
Yeah.
So we were pretty proud of that.
Yep.
Proud of Hunter. Pierce and I weren't here yet.
Nope.
So we didn't have the opportunity to work that event. But
yep, yeah, that was a crazy event. So hopefully we won't have anything like that anytime soon. But yeah, Hunter, do you have anything else to add about your career?
It's bound to happen again.
Yeah, true. I mean, yeah,
Yeah.
that's right.
unfortunately, it's
That's the way weather works.
it's
Yeah.
probably something like that will probably happen again. So.
Yep. Any parting words? Well, we're going to bring you on for our famously hot weather takes, but any advice for our listeners out there? Any tips?
Advice and tips for the listeners.
Yeah,
Our fitness tips.
yeah, fitness tips. We could take that too.
My phrase: movement is medicine.
Movement is
True.
medicine.
That is the key.
MIM.
Keep
And
moving.
probably eat-
no matter what. Just
Eat
keep
more
moving.
protein than you think you need to.
Yeah.
How many grams of protein did you eat the other day?
Ideally, you want to eat the amount of grams of protein of your ideal weight you want to be.
Okay, we're not giving out medical advice, but
Correct.
Yeah.
This is
This is just strictly
Generally-
what Hunter does.
generally our diets, we don't have enough protein. So.
Yep.
that's accurate.
Yep. So, thank you, Hunter, for sitting down in this interview. Okay, thank you, Hunter, again for coming on to the podcast and being interviewed with us. He's going to stick around for our next segment. Famously hot weather takes with Matt and Pierce and others.
And others, yes.
Yeah, and
So-
others. So, Matt, what are we talking about today?
So we're going to give our favorites and least favorites severe weather parameters.
Yep, kind of tie it into the word of the day.
Correct.
I'll start us off here. My least favorite severe weather parameter is the lifted index. What's the lifted index, Matt?
So the lifted index is another measure of buoyancy, like we talked about earlier. Basically, it's if you took a blob of air and raised it up like it would if a cold front was pushing it up into the air, what the temperature of that would be compared to what the temperature of the surrounding atmosphere would be.
Yep.
So the bigger that difference, the more unstable or the more warm the air would be compared to its surrounding environment.
Yep.
So why do you hate the lifted index?
I just don't think it's super useful. I don't think it's very useful. It's kind of it's used as a catch-all. Usually it's lifted to a standard height, like 500 millibars. Occasionally we'll talk about that. That's one of the standard heights we use in meteorology. I just don't think it's very useful. A lot of times there's a lot of instability lower than that in the atmosphere. Sometimes it doesn't take into account whether there's capping inversion, warmer air as you go up in height in the lower levels of the atmosphere. Different stuff like that. It's just kind of a catch-all, and I don't love it. I don't love it.
It's a fairly simple
It's very simple.
thing
yes.
to calculate, so that's why it's used. It's fairly straightforward to calculate. It has a simple interpretation,
Yep.
and it just can be a little bit overly simplistic.
Yes, that's very true. Yeah, there's too many caveats to it. My favorite severe parameter. Oh man, my favorite severe parameter. I love STP.
What does that stand
Significant tornado parameter. I love it. Anything over 1, it's an environment favorable for significant tornadoes. And let's throw out the caveat. It's kind of a catch-all.
for? All these parameters, like CAPE and stuff we talked about, can be overly simplistic, and they don't mean much on their own.
Yeah.
So STP is basically a composite parameter of
Yep.
multiple different parameters. So
Cave and
Pierce is sort of cheating.
Yes, I am.
Because it includes cape, sheer, and like
Okay,
lap
well,
frames.
I won't cheat. My favorite individual one, if I just want to look at whether we're probably going to have severe weather or not, 3-kilometer cape. There you go.
So 3-kilometer cape, again, is...
Cape in the lowest 3 kilometers.
Correct. So you just cut off and measure the cape up to 3 kilometers in the atmosphere above the ground.
That is my favorite one.
That one's very useful for, especially around here with our quasi-linear convective systems, the QLCS thunderstorms we get.
Yep.
It can help distinguish if you're going to have tornadoes or not in those types of environments. So
that's my favorite one, by far. Hands down. Matt?
I'm going to be lame and say I don't have a least favorite.
Boo!
I would... Again, we booed Nicole when she came on and took the easy way out with her cloud
you have
shake
to have a
last week.
least favorite one. I'll go get a mesoscale book.
Okay, so my least favorite, if I have to take one, is anything that's purely surface-based. So you can measure CAPE or convective inhibition, which is basically the opposite of CAPE, using just the surface-based air. There's more smart ways to do it, however you want to say it, where you can measure...
More wise ways to do it.
Wise ways to do it.
Wise.
Yeah, more scientifically accurate, physically accurate ways to do it, where you measure kind of the whole air in the lowest, maybe 1 kilometer of the atmosphere or something like that, and then you can develop CAPE from that. And they're more realistic about the air that's actually going to be adjusted into a storm anyway. So my favorite, Pierce kind of stole me with the 3-kilometer CAPE.
That's why I wanted to go first.
I like the supercell composite. That's another cheat. If
that's a good
Pierce
one.
took the STP. I like supercell composite because I did some work on it for my master's work. And
shout out.
Yeah, shout out to my...
That's a flex right there.
Yeah, that's a flex.
I like it.
That one I like, but then in terms of an actual single parameter, I really like effective layer shear.
Oh yeah, that's
that
good.
one is
Yeah.
very useful.
I like that one too.
For that is sort of a composite parameter in itself.
Yeah.
We can do a dive on what effective layer means, but
man.
Again, do an internet search on that, and you'll kind of get a sense of what it is. It's just a smarter way to measure, or a more wise way to measure the amount of wind shear that's in the atmosphere.
Very true.
That's actually impacting a storm versus just kind of arbitrary levels in the atmosphere, like 0 to 6 kilometers.
It's almost normalized. It's not normalized, but it almost is like masked based on the amount of instability you have.
Yeah. It's a way to measure shear, bringing some of the instability into it.
Yeah. Hunter, come on, Big Hunt. Oh,
Hunter has no...
Big Hunt. He doesn't care. No comments.
All
Wow. Right. Big Hunt pled the 5th. Wow. Okay, I'm gonna make sure to write that one down. Big Hunt pled the 5th. Mr. 4.6 himself.
Yeah, he's a true professional. He uses all of them and doesn't discount any of them. So.
Yeah, he actually takes in all of the information.
Well, what the lift did next, we didn't mention it, but it's actually quite useful for distinguishing where cold air wedges are. So we have cold air damage. It actually shows that pretty well. Ironically, because those are like extremely stable air masses.
Yeah.
But lift and index can help show if you have a surface wedge developing.
Yes, that's very true. Also useful for that, theta E. I want to give that a shout out. I just love theta E.
Theta E, that is...
equivalent potential temperature.
There you go.
I don't think we're going to go into that.
No.
We're not going to... It's a good way to measure the moisture in the atmosphere, but we're not going to go into a deep dive on that. It's
moisture and stability.
Yeah, moisture and stability. It's it gets kind of complicated, but that one's a good one for you weather nerds out there. Look up theta E. So, okay, well, I think that's a good episode there, Matt. I think that's elite territory. That might be a...
You said it was going to be fire.
It could be a 99th percentile for us, but here's what we do. We only put out 99th percentile material, so I guess you're going to be getting used to it. So, only 99th percentile podcast here.
Yeah, only the best, right? That's why we brought Hunter on.
Yep, that's why we did. We brought him on. He's the best at running 40-yard dashes in this office by far. Not even close.
That's a fact.
Well, I guess we'll wrap this one up. Thank you to Hunter, and we'll check y'all next week or whenever the next one comes out. Adios.